Can everybody hear me? Wait, hold on. Oh, can everyone hear me? Still no look.
Yes, we can hear you.
Oh, okay, wonderful. All right, welcome everybody. So yeah, so apparently we were supposed to have thunderstorms and storms, but maybe that's just my neck of the woods. All right. Anyway, how's everybody doing today? Everybody doing all right?
Yeah.
Yeah. All right. Everybody's feeling very quiet. Yeah. So any issues with the individual project? Everybody submitted their project. Looked at them yet, so seeing what they look like. Now people are saying oh, the word limit is too short. Here's the thing you have to understand. The game changes between bachelors and masters. When how much you know, right?
Yes.
It was literally like the more you know a lot about the subject, right? When you're doing your masters, it has totally changed. So you're trying to create the biggest impact on the person. You're trying to create the base, both in terms of time, right? Both in terms of time, but at your level, people at your level, and the people you report to, they don't have time to listen to 20 page, right? They want, that's really what they want. You understand? They don't have time for notice. But in reality, most courses, right? So for example, like let's say one graduate class, um, one graduate class. All right. So the idea is that the amount of information that you have to process is so much dense information, right? In other words, really, when you are grading a piece of work from him through it, right? You kind of run through it very kind of quickly. Um, Graduate student, it's supposed to be super dense information. So it's only and very kind of you have to kind of really dice together, see if it's product, see if it has a high. Okay, so the whole idea is that you need to be able to, as a graph, to the point, high impact. every sentence you say, you know, is adding significant to the subject, right? Everything that you say is supposed to be pushing the knowledge level forward, right? Yeah, you don't have time for, 1,000 words. You don't have space for 1,000 words. All right, it's saying that my internet. Have you guys started the group project work? Hmm? How much is the group project worth? Why, it's like, like, see a bunch of people on the call, but it's like only Rashmita is speaking. Only Rashmita is speaking. All right, yeah. So make sure you've started on the group project, and remember that the group project is worth how much? I think it's worth 50%. All right, let me see if I can find this notebook that I was going to show you guys. All right, hang on a second there. Hang on 1 second. Hang on 1 second. Let me just share the screen. Oh, wait. Screen. Share this. Well, I'm the host. That's weird. Sharing is not turned on. Uh-oh. What? Okay. All right. I know what. All right. I clicked on the announcement. I clicked on the link in the announcement. I have to log in as me in Zoom and then click on the scheduled meeting. All right. Hold on one. Sorry about this. All right. All right. My meeting. is it April 2? I think this is it. All right. Is it? Nope. Meeting summaries, recordings, docs, clips, whiteboards. Let's see. Schedule. All right, meetings. Come in 10:30. Yeah, I think this is it. All right, join now. Okay, wait. All right, hang on a second, guys. I think I have to leave. All right, okay, good. All right, so I'm on. All right, so hang on 1 second. All right, okay, good. So today we're going to look at callbacks. So, all right, can everybody hear me? Can everyone hear me?
Yes, Professor, we can hear you.
Yes, no? Can everyone hear me?
Yes, Professor, you're audible.
Yes, Professor.
Yes, we can hear you.
Okay, good. All right, okay, so the idea is that you can, okay, all right, great, thanks. All right, good. Now, also, can you see the notebook that I'm sharing? It's called Week 2 Implementing Callbacks in TensorFlow. Hello?
Yes,
Hello?
Professor.
Yes, sir.
Hello? Okay, all right, yeah. So today we're looking at callbacks. So the idea of a callback is that it allows you, it's a base day program to report back on what is happening, right? On what is happening with the model, yeah? And the idea is that instead of just letting the model run wild, because normally when you're training the model, you're training it for a set number of epochs, right? And there's a couple of problems with this. The first problem is that each epoch is costing compute, right? Now, the idea of compute is, like we said, compute is computer resources, the level of computer resources you're using multiplied by the time that you use it, right? So put it this way. It's like you have to transport sand and stone for construction, right? And it's like you might have one truck and you use it for 10 hours, right? Or you might have 10 trucks and you use them for 1 hour. Did I say 1 day or 1 hour? Let's say 1 day, right? So 10 trucks, 1 day, or 1 truck, 10 days, right? Because you're hauling sand and stone to a construction site, right? So the truck is like compute in the sense that the more trucks you have is the less time you need. The less trucks you have is the more time you need, right? But the idea is that there's an overall payload, yeah? And you compute it as 10 trucking days, right? It's 10 trucking days. So, all right. So, let's see. Let's share, no, let's share the entire screen. Yeah, let's share the entire screen, right? Right. So basically you have 10 trucks for 1 day, 1 truck for 10 days. That's 10 trucking days, right? It's similar to the concept of you have 4 painters for 1 hour, right? Or 1 painter for 4 hours, right? That gives you 4 painter hours, right? 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 You guys are masters level, you know. So for you, it's more than just, okay, how do we write code? How do we kind of, how do we train a model? You have to understand the management aspects of it, right? So again, 1 CPU, right, for 5 minutes, right? Or 5 CPUs for 1 minute, right? Equals 5 CPU minutes, right? And this is called compute, yeah? Not computer, but compute, right? Right? Instead of talking about trucking days or painter hours, we talk about compute. Compute is the amount of computing resources you use, right? Times the period for which you use the computing resources, right? Now, for example, suppose you have a suppose you have a multi CPU setup, right? It means that you alone could use 4 CPUs for 1 hour, right? Or or 4 people could be training models while your other 3 teammates or your coworkers, your teammates, your colleagues, right, are also training models at the same time, right? So the idea is we have to account for the compute that we use. So let's say you have a model and you're training it for 50 epochs, but then the model reaches its maximum accuracy after 10 epochs. What does this mean? Think about what this means for a second. You have a model, right? You've trained it for 50 epochs, right? Each epoch takes a minute, right? But the model achieves maximum accuracy after 9 epochs, right? So training for 50 epochs, right? And after epoch 9, you reach 97%, or let's say 87%, right? Epoch 7, epoch 8, right? 86, 85, etc., right? But after epoch 9, you got to 8, you're still at 87%. And epoch 11, epoch 12, 13, 14, 15, 16, 17, 18, right? No, and in fact, you're lucky if it stays at 87%, because as we pointed out in the previous class, it might be 87, 86, 87, 85, 84, back to 86, back to 87, right? Back to 86, right? Epoch 80, epoch 19, right? Back to 85, epoch 20, right? 84, and it's bouncing up and down. So what this means, right? At 1 minute per epoch, you wasted 41 minutes, right? Good. You wasted 41 minutes. Now, chances are go and have some coffee, maybe go and answer some emails. Maybe you make 2 phone calls, right? Maybe you do something else in the meantime, right? So maybe so you have to understand something. At this point, so normally if you're not going away to do something else, if you're not going away to do something else, then it means you're wasting compute, right? That's the compute resources that somebody else could have been using the computer for, right? You've tied up the computer, the CPU, right? Most likely it's on a server somewhere, right? And you've tied up this compute in such a way where somebody else is unable to use that compute, right? All right. Now, if you're sitting there waiting on, watching it, right, which would be kind of silly. But if you're sitting there watching it, then you've also wasted your time. All right. So you've gone away, you've drunk some coffee, you've answered some emails, you've made some phone calls, you've signed some papers in the meantime, right? So in your mind, you're saying, well, the 41 minutes isn't wasted. Well, the problem is that here's a couple of problems. First of all, it's a distracted 41 minutes, meaning that it's not 41 minutes in which you're intensely focused on something else, right? It's not 41 minutes in which you're totally invested, totally committed to some other high intensity task, right? Normally you're doing something that, and if you're super, super good, if you're extremely good at multitasking, right? Then maybe you're doing something else that is also intense, right? But chances are you're back and forth, right? But not only this, right? You've not only wasted 41 minutes of compute, right? Right? You wasted 41 minutes of distracted working time, right? But also, model is taking 5 times as long to train, right? All right. Now, obviously, you're not gonna let it. When you come back and see the report, you're not gonna, train the model for as many epochs. But the point is, the time that you've allowed the model to train and the model is not improving, right? It's wasted time, right? And it's wasted on several dimensions. It's wasted in terms of tying up the computing resources, wasted in terms of tying up your time. And the point is that it's taking longer to train the model. So the overall duration of the project is going to be that much longer, right? Maybe you have 2 days to create a model, right? If your model is taking more extra time to train, then you're likely to miss that deadline. All right, okay, so we have callbacks. So the callback is a feedback loop, right? It allows the model to report back on what is happening, right? And it allows you to control the training automatically, yeah? And so we have callbacks, right? And so the idea of a callback is that the model reports back on what is going on. Okay, so let's look at this callback. All right, so first thing you need to do is to define the callback class, right? So you define it, right? Now, I should have asked here is a lot of you are not programmers, is that all right, so you have this thing classes, yeah? And the idea, 2 basic types of code in programming. Procedural, right? Where essentially you create what are called functions where in the code, yeah? But then you also have classes. Classes allow you to create what are called objects. A class is basically reusable code, create several objects belonging to the class, right? And each object will fit that mold. It's kind of like a cookie cutter, yeah? It's like a mold. And the point is that allows you to create the objects in a very sort of structured way. Right? So that the object always, they actually have 3 things. They have methods, which is a function that we're normally used to in procedure. They have properties, right? Right? All right. So anyway, the truth is that you don't need to know, you don't need to understand it. Super, super good as a programmer. You just need to be able to use it, right? So anyway, we're looking at this class, and it's called my callback, right? And the point is that within it, there's a function. And within this function, it's on epoch end. So what we're basically saying here is, this is what you're going to do when the epoch ends, right? Right? Now, in this particular callback, what we're saying is, right? We're checking the logs. Then if the accuracy is greater than 0.999, or in other words, 99.99%, then what we're saying is stop the model training, right? That's essentially what we're saying with this callback, yeah? And so the idea is that we can stop model training at this point. So what this means is that if we have a very long, if we're training a model and it's taken a very long time, yeah, we don't have to sit down and watch the model train, right? Because the point is, while we're training our model, it's kind of like if you go to the gym, right? If you go to the gym, you have a limited set of weights in the gym, right? You have limited machinery in the gym, right? And then people they what you call work a set. So like let's say you're working your biceps, yeah, and you're working your biceps, and so you might use a particular machine that works those biceps, and then you use you use a machine for a set of 3 sets of 10 reps, right? So meaning, okay, let's look at what a bicep machine might look like, right? Look at what a bicep machine might look like, right? All right. All right, so you have this bicep machine, and basically you're going to pull up on this device, basically 10 times, right? So you have this weight, and you're going to pull up on these 2 handles, and you might do it 7 times, 8 times, 10 times, right? Now, by the way, when you weight training, right? 10 years I was major into the gym, kind of slacked off and fell off. But anyway, but the point is that, so you can put on a lot of weights, right? And then, so let's say, for example, you put on 100 pounds, right? Or 50 kilograms, yeah? And then you might do 10 reps, right? You pull up on these 200 bars, and this is going to work your bicep right here, right? Your biceps are the muscles right on the front of your arms there. Then, of course, you have the triceps on the back, yeah? All right, good. So I might do 50 kilograms, 10 reps, right? Or you might do 70 kilograms, 5 reps, yeah? That's going to build strength, yeah? So more weights, less reps, build strength. Or you might do 15 reps, right? Oh, sorry. Uh, 50 kilograms. So we said 70 kilograms, 5 reps, right? So that's going to build strength. Or you might do 25 kilograms, 15 reps, right? And that's going to build tone, right? That's going to tone your muscle, right? It's going to make it look nice and sharp, yeah? Your muscles are just going to pop, yeah? All right, very good. So the point is that, you can do these reps. Now, you see some people go to the gym, and basically what they're doing is they go to the gym and they sit down on the machine. And okay, so you do these sets of reps. You might do 3 sets, right? So you do 10 in each rep, and then basically you're gonna rest between the reps, or between the sets. Yeah. So you do 1, 2, 3, 4, 5. Boom. Right? So you do 1, 2, 3, 4, 5 of 70 kilograms because you're building strength. Good. Then you're gonna rest because your muscles need time to recharge and recover, right? All right, beautiful. So now you're gonna get on your phone and you're gonna start texting and you're gonna start answering emails, right? Now some people are gonna sit down on the machine and tie up the machine, right? And you can even find YouTube videos about this, right? On social media. Tie up the machine and they wait for their muscles to rest, right? Now you might have somebody walk over to you and say, listen, can I work in a set? Yeah, sorry about that, guys. I'm back. Can anybody hear me? Can you guys hear me?
Yes, sir.
Yeah, sorry about that. I had a lightning strike and then I lost power. Lost power for a little bit and then had to restart my computer. Sorry about that. Yeah, yeah, sorry about that. Power over here is kind of unstable. I live in these old apartments and yeah, anyway, all right. See if we can get set up again. All right. Okay, yeah. So anyway, all right. So anyway, so we're working on our biceps. And basically, like I say, you sometimes you have people will actually come by and say, can I work in a set? Right? They'll actually ask you if they can work in a set. And basically, the idea is that while you're resting your muscles, you know, they can work in their set, right? So you're not tying up the machine, right? Okay, so anyway, let's see if we can restart this, bring this back up. Hang on 1 second. Hang on 1 second, listen. So yeah, so anyway, so the point is with callbacks, you can tell it. So the callback, in a sense, the callback is like your muscles tell it. Okay, so the other thing about weight training is this. The other thing about weight training is this. They have what's called, and I hope I'm getting this term right. They call it wait, hold on a second. Let me see something. They call it, I think the term might be like repping to failure. Yes. Yes. Okay. All right. Very good. So they have this concept in weightlifting called repping to failure, right? Repping to failure is like you're training the muscle. Because the idea, you know, with muscle building is that you build muscle by lifting weights, right? Because the idea is that when you repeatedly lift the weight, right, the muscle actually gets damaged, and then you know you take your protein, and then you know the protein rebuilds the muscle, but it rebuilds it stronger, right? So the idea is, so some people do what they call rep to failure, meaning you're lifting weights until you can't lift it anymore, right? So instead of just doing like 10 reps, like instead of doing a fixed number of repetitions, yeah? Instead of doing a fixed number of repetitions, what they do is they repeat until they're unable to lift anymore, right? So in a sense, the weight machine, so in a sense, doing reps to failure is like implementing the callback, right? Because the idea is that, I mean, if you're just, no, there's a slight difference. There's a slight difference. If you're doing, for example, let's say you're doing a fixed set of reps. Let's say you're doing 10 reps, but in reality, you could be doing 13 reps, right? Let's say your rep to failure would be 13 reps. Then it means that you're under training. You're actually under training, right? in a sense. But you have to be careful though, because you know, some people don't believe that it's a good thing. Like, for example, they say there's a risk of injury. Pushing to failure, right, increases the risk of injury. I don't know if you guys can see this. I guess you guys can see what I'm saying, showing you here, right? Drawbacks and risks of training to failure, right? So the idea is that if you think of it as an analogy, the idea is that watching the is that training it for a fixed number of epochs, right? Training it for a fixed number of epochs, it might be under training or overtraining, right? We saw where, for example, if you're training it for 50 epochs, then it may have started overtraining by the time you reach 9 epochs, right? Now, in the muscle analogy, it's like you've rep to failure, but you're still lifting, even though that's not possible in the physical muscle world. It's not physically possible to keep lifting after your muscles have failed, right? Even though it is kind of possible, it is kind of physically possible, because you could be totally struggling, right? Anyway, the idea is that repping to failure is like implementing callbacks inside your muscles, right? Because it's like your muscle is giving you the feedback to say, okay, stop training because, oops, it's like your muscle is saying, stop training because, you know, it's we've reached the maximum, we've reached the limit. All right. Anyway, so not some perfect analogies, but the idea is that, you know, the callback stops the training. All right. So here's what a callback looks like. Class callback, right? The method it has is a definition. This is a function definition, right? You might know it as a function definition, right? Now, if you're not a big programmer, I mean, don't worry too much about it, right? Because the truth is that most of what people do is to kind of borrow code and reuse it. Yeah. So don't worry too much if you don't understand it perfectly. All right. Anyway, you guys give me 1 second. I'll be right back. All right, and I'm back. Yeah. So the idea though is that you know, there are some analogies between using callbacks and repping to failure, right? Right. So right. All right, very cool. There's some analogies. All right, okay. Let's see how the callback actually works now. Okay. So here we have your training function, right? Here we have it in a function. And in Python, it's a define function, right? Function name and what you call the parameters. I'm sorry, but this is some programming right here, right? All right. So you have your remember the idea of a function is that you can call it from anywhere in the code. Yeah. Has a function name, has the parameters, right? Xtrain is the Xtrain and Ytrain are, of course, the training set, right? Your features and your labels, right? Callbacks equals my callback, right? So here you've created a callback object using the callback class, yeah? See, class my callback, and we're creating this callback object, right? Equals my callback, yeah? All right. You create your model, and you have the different layers of the model, right? You have your flatten, you have your dense, right? The output layer, dense layer, etc., right? You have your 10 classes. You have your activation function, softmax. Remember how softmax works? It's really 10 probabilities. You have 10 probabilities representing the probability for each class. And the class that is predicted is actually the class that has the biggest probability, right? Compile your model, right? You have your loss function, right? And your accuracy metric, yeah? And then you have a slight difference here. Instead of just model.fit, right? Which would train the model. Normally we would just say model.fit to train our model. But this time we're saying history is equal to model.fit. So what this is going to do is it's going to train the model. It's going to fit the model to the training data, right? For 10 epochs. And it's going to implement the callback here. Yeah. And so the idea is that each time the callback will check the history, and once the model accuracy goes to 99%, then it will stop. Yeah. It will stop at 99%. All right. Okay. But over here is kind of bad, and I don't want to risk damaging my computer. So I'm going to call it a day early. Any questions on callbacks? Any questions about callbacks? All right. So to reiterate, can everybody still hear me? You guys hear me?
Yes, sir, we can hear you.
Okay. Thank God for Rashmita. Rashmita is always going to answer. Let me tell you something. When Rashmita leaves this institution, she's going to get an amazing, totally amazing recommendation from me. Totally amazing. All right.
Thank you so much, Professor.
No, absolutely. Rashmita has done a couple of classes for me, with me, and trust me, can always, if sometimes I have to tell Rashmita, okay, all right, give others a chance. But if nobody is stepping up to the plate, Rashmita is there. Rashmita is a born leader. Rashmita is strong, proud, born leader. Indomitable spirit. She's gonna go far and high, guaranteed. All right, anyway, so to reiterate, a callback allows you to implement a feedback loop in your training, right? It checks to see what is going on with the model, right? It checks the history, right? And so instead of just simply saying model.fit, we say history equals model.fit, right? History equals model.fit, right? And in that, we implement our callback. Callbacks equals the callback that you created, right? The callback object that you created, right? Here, yeah, callbacks equals my callback, right? It's so the callbacks object that you created from the my callback class, right? Remember, the class in programming is a template or cookie cutter or a mold. It's a mold or a template that you can use to create several objects. Yeah. And all these objects will have the similar behavior, right? That's the idea of an object and classes in programming. It allows you to create reusable code, which can be redeployed easily. And you maintain the class one place, maintain the class one place, and every time you create a new object, it's, if you updated the class, then the object is automatically updated. Yeah. All right. So anyway, so yeah. Instead of just saying model.fit, you have history equals model.fit this time, right? Give it your training data, your number of epochs, and you give it your callbacks, right? Your callbacks equals, and then you have your callbacks equal my callback from your my callback class. Yeah. Yeah. And this, of course, is the library that it's using. Within it, you're going to have the function. And all it's going to say is if the accuracy, if you're measuring the accuracy, this is just what they call error handling, right? Just to make sure that doesn't crash, right? But really, this is the functional part. If the accuracy from the logs is over 99%, right? Then you're going to print a message and you're going to stop the model training, right? Yeah, you're going to stop the model training. All right, okay. That's basically what we're going to do for today. Now, in subsequent sessions, we'll see where we can also use a callback to do other things, like we can control the learning rate, right? We can control the learning rate. So, you have a learning rate scheduler, which basically can automatically decrease the learning rate. You can automatically decrease the learning rate using decay, learning rate decay, right? You can use, we started to look at that last week, right? So you can have a learning rate. Remember, gradient descent needs a learning rate that is reducing 5e minus 5. And you can say equal to that times 0.95, right? And you keep decreasing the learning rate, right? And so you have that nice gradient descent. Remember, this is in the context of gradient descent, right? Where what you're trying to do is you're trying to reduce the learning rate so that you don't kind of overshoot. You're reducing the learning rate constantly, right? So that you don't overshoot, right? Otherwise, you start to bounce back and forth. Right? So you're reducing the learning rate using learning rate decay. You can also do step scheduling. You can say equal to 0.95 of that, right? Times that, right? Was 0.95 times that, right? But this time, you tie it to the original learning rate, right? Yeah. $B, $1, right? So this time, oops. Oh, sorry. right? Was that times that equals that times that, right? I have step decay. I have a different, oh, oops. Oh, oops. Times C2, $B1 times C, right? You have step decay, right? But you can also control it through what you call it, can control it through callbacks. All right, people, that we're gonna call it that for today. All right, any questions?
There was one thing that I wanted to ask, Professor. There,
Yeah, sure, Rashida.
when you mentioned that we want 10 epochs, but what if the model doesn't get to the level of accuracy? Like, if it doesn't get 99% accuracy, will it increase the epochs by itself?
Oh, no. So what you could do is, no, so what you'd actually do is, no. So what you would do is you could do, for example, you could do 100 epochs. You could
Okay.
originally set it to be 100 epochs. So you could say 100 epochs. But the point is, at whatever point, so you have to set an outer limit. So this is going to be your outer limit. That's a great question. Excellent question.
Okay.
This epochs is an outer limit,
Mm-hmm.
right?
So whenever it
Meaning train it
reaches
up.
99, it is going to stop.
Yeah, whenever it hits 99, it's going to stop.
Yeah, I
Yeah.
was just wondering because you mentioned 10, and what if it doesn't reach 99 until it's 10? So,
All right. No, that's a fantastic question. So this is a stopping condition. So, well, put it this way. This is an early stopping condition. Yeah. This is early stopping.
okay.
So it's going to train it for a maximum of the epochs that you put here. But as soon as this condition is met, you can set pretty much any condition you want here,
Mm-hmm.
right? Right? You can set any
Yes.
condition you want here. But as soon as that condition is met, it's gonna stop.
Okay.
Yeah. Now when we look at when we come back on Wednesday, we'll see, for example, where in this case, let's go back to this case. In this case, right? In this case, it didn't just hit 87. It hit 87 and it started to decrease, right?
Yeah.
Right? So it hit 87, then went 86, 87, 85, 84, 86, 87, 86, right? The point is, if we'd set it to be over 87, greater than or equal to 87, then it would not only have stopped here, but you see, by the time we came back and checked on it at epoch 20, the accuracy decreased to 84%. So we end up with a worse model, right? So we can also take out model snapshot, yeah? And we'll also look at that on Wednesday, right? So this is an early stopping condition.
Okay.
And you have to put the maximum amount of epochs that it could possibly train for. Now, also bear in mind that if it never reaches the 99%, then it will
Mm-hmm.
never stop. It will go all the way to the maximum, right? So you're going to
Mm-hmm.
use up all of that compute all the way to the max, right?
Okay.
Yeah. But this also helps with, to prevent overfitting because, again, when you train a model, when you overtrain a model, then it gets fit too well to the training data, and then it tests poorly on the test data, right? It doesn't what you call generalize well. Yeah. It gets fit too well to the training data, and it doesn't predict values on the test data well. All right, yeah, let's call it that for today, and then I'll get some attendance from the Zoom meeting. Yeah. All right. Any more questions?
No.
But yeah, great question, Marshmitto. Yeah.
Mhm.
Great question. Yeah. Any more questions?
No.
All right. Well, in that case, I'm gonna call it a day. All right. I'll see people. Stay safe. Stay safe. Stay safe. Don't venture out into this weather. I think it should end by 1 o'clock. But anyway, in the meantime, stay safe. All right, everybody. Have a great day. See you on Wednesday.
You too, Professor. Thank you.
All right. Thank you.